Thank you very much for this invitation. I want to thank all the people of the organization who supported me. I am Stefania Bandini, and as you can see, I am not an architect. I am not an architect, and I have been invited just to show what is part of my research. I come from the science environment, and I am at the University of Milano Bicocca, and my research field is complex systems and artificial intelligence. And I have the honor to be also a guest professor at the Tokyo University, and it means that I have the opportunity to see an international view of the topic I'm going to talk. And as you could see, the title of my presentation is Disciplinary Convergence in the Era of Complexity, the Case of Crowd. But let me see word by word what this title is meaning. The first term, that is a new term that I want to focus on, is the word convergence. And it means that convergence is a way to look at big problems. Thinking by big problems is the new challenge for the development of knowledge and the development of new projects and new educational methods. The second word is complexity. Sometimes we confuse the term complexity with the term of complication, and we will see something what it means and what are the computational scenarios in complexity era. And I want to focus a little bit on one of the main concepts of complex systems. This is the power of self-organization. The third term that is in the title is the term crowd. Crowd and the science of crowd is one of the main topics of my research. Now it's not the only one, but it's one of the main. And through the concept of crowd, we will see as we have to come back on ground, because now all our life and all our environment is full of internet-like communication. And we will see that the knowledge of the gathering of people is one of the main issues, and maybe could be a little bit intersection with architects that usually are not so concerning new models and new perspective to support the simulation of the behavior of a crowd as a complex system. So, let's start with convergence. If you go on the internet and as in this case, in the Web of Knowledge database search under the topic multidisciplinarity, interdisciplinarity, or transdisciplinarity, this is the growth of the literature and the papers invoking this kind of words. And usually we use this term in a synonymic way. We don't mind, we use the term multidisciplinarity or interdisciplinarity like synonyms. It is not, but let's see what is the some meaning of it, of this kind of word, and moreover, what is the different approach that we need in order to merge the knowledge coming from different disciplines. Convergence is required to see why it is so important and the frequency of these terms are growing. Because thinking by problems is the real challenge of the next decade or so. For instance, in this case, the three main topics, big problems I am involved with, so I know better than others, are aging society. As you know perfectly, we are living in an aging society because of the longevity of the people. Longevity of the people is due to the quality of food, the quality of health, medicine, and the quality of living places. So advanced countries are facing the problem of aging society, and it is not possible to ignore this. Second, disaster resilience. As you saw in these days in Italy, but all around of the world, disaster resilience, and the term resilience is a new word. I want to give you new words that will be fundamental in the direction of the research on the development of innovation. And disaster resilience, how to recover after a disaster, is another big problem where a lot of different knowledge is converging on. And the third one is smart cities and mobility, because the models of smart cities and mobility are global. It is not possible for this kind of three problems, for instance, to think about only our problem and the problem of our single countries. I give you an example. It's a very, very good picture I had from a publication from National American Press, that is military, substantially, and on what is a structure of catastrophic disaster response. You see, with this picture, you can see what is the kind of knowledge that are involved in order to have a good catastrophic disaster responses. And as you can see, the two places, education and information sharing, are at the basis, and ethical consideration, legal authority. And you see that federal government, you can take it off, nothing is happening, but you have not to take something that is on the basis. So you see that if you face big problems, starting to build what are the basic bricks that are involved in order to face a big problem, this is a very, very good metaphor to do that. So, come inside in a sort of joke. Look at this. This is a way to communicate. I had the opportunity to work with an architect on these topics. The only one. I never worked with architects. That is, maybe you know him, it's Vito Acconci. This is a game with you see that there are some words. Real world research problems, local, nature, society science, sharing, true, rare, difficulties. You see that are magic words. And all these words are evocating basic concept to you. But if you put these words in the context they are extracted from, you see that these sentences are designed our future. The real world research problem that scientists address rarely arise within orderly disciplinary categories, and neither do their solution. For architects, it's quite usual, but the people from science had an educational and institutional structure that is hard to touch. So you see that rethinking interaction across domains and scales, nature and society, science and democracy, the global and the local, as well as the past, present, and possible futures. I'm not going to read all the places, but you see that there is a need to do something about the sharing of knowledge to face big problems. But let me do something that is a little bit boring, because we have to go to some common language and we have to understand definitions. So the word disciplinary, maybe all of you know, but it is a particular branch of learning or body of knowledge. And we can agree on that. All we know what is discipline. And unidisciplinarity is a process in which a researcher from a single discipline, field, or area, they are addressed to a common question, problem, topic, or theme. That is very typical from hard science, for instance, to be unidisciplinarity. But the surprise is coming when we look at the word multidisciplinarity. Multidisciplinarity is a process of juxtaposition. It juxtaposes two or more disciplines put together, only put together in order to use, one discipline can use the result of another discipline. If you think about architecture, of course, when you build a building, you use physics, rational mechanics, through engineers, in order to make counts and establish. But you have some novelties when it is not just a juxtaposition. So when we use the term multidisciplinarity, we are using a sort of team, a military team. Each people know exactly what to do, and the interface between disciplines is only a passage of data and information to focus with a big. But if you see, the word interdisciplinarity is a little bit different. And we usually, in common language, me too, I use in a similar way these two terms. Interdisciplinarity integrates information, data, methods, tool, concept, theories from two or more disciplines focused on a complex question, problem, topic, or theme, incorporating tools and methods, integrating them into the practice, generating a new conceptual framework or theoretical explanation and larger scale initiative. So, interdisciplinarity, that is a magic word that is in the plans of big institutions and university, because now is mandatory. You have to consider that in the planning of the international research, there are some recommendations. And this word is a word that is it means that putting together information and knowledge coming from different disciplines, you are expected to have a new kind of result. But the very new word, that is another word that is emerging now, is transdisciplinarity. It transcends disciplinary approach through more comprehensive frameworks, and we are expecting to find a sort of new discipline. The best example of transdisciplinarity is in genomic science, where the basic research coming from theoretical artificial languages in computer science, very theoretical mathematical stuff, was determined in a very, very serious way the growth of the research in genomics, because these artificial languages could give models for the interpretation of DNA. And bioinformatics, for instance, or new trend in biology, they came from the fusion of these two kinds of knowledge and results in discipline. So this is just a question of words. We are starting from the beginning. And this is it's called the MIT model, multi-inter-transdisciplinary model. This is a scheme where you can see what is the role of each of them. And it is, you can control if your research is multi or trans or inter, okay, and you have to check. And moreover, we have some kind of recommendation coming from institution. For instance, I give you an example of a model that has been developed at the Imperial College London, pushed by the needs of mixing knowledge. This is a proposal that is very, very nice. This is very nice because you can see that you have core disciplines, you have big problems, healthcare, energy, environment, security, and the societal and economical benefits are shaping this structure. This is the first step towards a new conception of how to integrate knowledge from the institutional and educational part from scratch. What are the dangers of this kind of scenario? First, we have mainly, I found, three kinds of attitudes. The reductionism, I call the cocktailism, and ingenuities. And you can see from left to right, you can see that the first one is owned by, for instance, people from hard physics or some engineers. And in the last part, you can see some kinds of social science, for instance, or some humanities. So you can see that for people from physics, every problem can be reduced in a sort of velocity, mass, and some differential equation. The cocktailism that is very dangerous is put together in a room some people from different disciplines, shake, and we will obtain a new result. And it is typical of very, in some ambit. I don't know, I put people around let's put the people around the table and let's see what is emerging. The third one is ingenuity. I take some mathematical formula coming from a discipline, I put it in my discipline, so my discipline is sounding, is best, is scientific, and so on. But we have a lot of problems. This is a list. And the main problem is the educational problem, because it's very difficult to design a new model how to grow people in this area. But at this point, after all this explanation, and after visiting the vocabulary, the literature, the models, I had some doubts. Something is not sounding so mechanical, another way. It's not fluid like it is required. But may I decide from the beginning what kind of the research I am doing, if it is trans, inter? It is not possible, because I have to see at the end what is coming. So a new word came, and I read this literature from United States, that is the word convergence. So I'm coming back to this word that is in the title to explain you through this part why we use this term. And coming back from magic words. Look at the words. They are very, very different but they are sounding with our reality, and I think that they are fitting on the disciplines involved in your job and in your knowledge, from architecture. In general, I am saying from design to urban. Architecture, I am using this term in a very, very way. That is convergence, problem solving, industry, innovation, web, funding, stakeholders, boundaries, investigation, innovation. You see that there are words that are evocating all another view in your mind. And if we contextualize it in the sentences, it is sounding in a modern way. Convergence is an approach to problem solving that cuts across disciplinary boundaries. That is completely different from the MIT model. Convergence integrates knowledge, tools, and thinking from life and art science, physical, mathematical, blah, blah, to tackle scientific and societal challenges that exist at the interface of multiple fields. You see that in this perspective, all of us could have a new way to fit your knowledge, into big problems. And it is very important to see that convergence provides fertile ground for new collaboration, engaging stakeholders. It is not possible at now to think to exclude stakeholders in the chain of the growth of knowledge. How to foster convergences? Establishing effective organizational culture, structure, and governance. The problem is not to put together what is the inspiration of the governance in this process. Addressing disciplines, development, and promotion needs. Creating education and training programs. Forming stakeholder partnership. Obtain sustainable funding. It's not possible to face this kind of enterprise, not to take in consideration that this is no problem, this is a good idea, this idealism is against the urgence of our society to see our knowledge integrated with the knowledge of all the other people focused in problem solving. Few words about complexity. And you see that complexity is fitting with the concept I introduced till now. It requires an entire lesson. So I have only a couple of slides on complexity. The main point of complexity is that I have a set of single actors or agents or entities interacting with local rules, producing an emergent behavior. In physics, in a physical way, there is a very, very good example that you know very well, that is the ola in the stadium. Each people is obeying to a simple rule that if the people at my left is standing, I stand. If he's seated, I sit. And it's the only one rules. And the emergent property is the production of a huge global system. This is the main property on complex systems. And it is based on the notion of the self-organization of living, artificial, natural, social systems. And it's a completely different way to see the reality, because it is new, all the people is blah, 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 about complexity, but complexity is it's not easy to tackle. For instance, Facebook, this is a picture of Facebook, the network, the formalized network, this is just a shot, seeing that is a self-organizing phenomena, because we go from biological or physical systems till social new technologies and artifacts. So, come back, as I told, on the ground. And let me talk about a typical complex dynamical system that requires convergence to be studied. This is an example. I could give other examples, but since I am working on that, I give you this example. The first action is, but do you know what is a crowd? Can we see that this place is crowded? This is a crowd. Usually we have the term coming from classical physics and engineering that we see that it's not very crowded because we think about density. But it is a crowded space. I am asking what is a crowd and why I am saying that it is a crowd. It is a crowd because I am the discharge and you are together looking at me in this moment. And never mind if your neighbor is very close to you because you lose your identity when it is when I stop talking, all the people is going to ask for the space. So it is a basic principle that is very, very different from modeling mass, velocity, direction, we are used, or fluid dynamics, and so on. But never mind. This is another research. I am not. And usually we think about crowd that is a sort of water. We are not water at all. So I need a definition. I need a definition. This is the natural language. The definition I adopted is a crowd can be defined as a gathering of people standing in a close proximity or seated in a close proximity at a specific location to observe a specific event who feel united by a common social identity. We have a social identity. And despite being strangers, are able to act in a socially coherent way. So think about stadium, concerts, gathering, and you see that this definition, but this definition requires a different mathematical and computational model to be created from scratch. So, what is my job is crowd modeling and simulation through complex dynamical system, facing convergence needs and facing computational challenges. This is the sense of big research. And it is not possible that one single researcher can do that. So, about convergence needs, look, you imagine, we read a lot of papers from sociology and from psychology, from physics, at the end, I choose Elias Canetti. Elias Canetti is a Nobel Prize for Literature. He spent 38 years of his life studying crowd. And in his book, Crowd and Power, that is Mass and Power, that is a basic book, the first 100 pages, they present a fantastic taxonomy and ontology, the name of ontology of crowd. It is fantastic for us because we could classify different behavior starting from different environment. Usually it is read by philosophers and it is perceived like a sort of very, very boring book. And we made all the formalization, and it is really a light. And the basic principle of Elias Canetti is that for all the people has the fear to be touched. But when I realized that the fear to be touched is the first one, that is a sort of force, a dynamical force, or repulsion, that I need another kind of model. And we decided that the best model, and I know that architects know very well this concept, is proxemics. Because proxemics is a method for have measurements. Without number, I cannot develop a computational model. So we started from Elias Canetti. We put together to the Stephen Hall, but the Edward Hall theory is static. Now is used in the design of spaces for work to see the constraint of the distances if the people is in a narrow place. So we have not a dynamical theory of proxemics. And crowd is a dynamical phenomenon. So we needed to have another change of mind. That is a sort of Copernican revolution. Because if I say to you, crowd, all of you, I am sure, have the idea of all the particles that are moving and gathering, and then when there is not the discharge, they come out. But it is not so. Because the crowd is a crowd of groups. It is impossible to find gathering people that is not in a group. Families, friends. The only one case that you can consider single people is commuters. Commuters in the rail station could be considered to be alone, but it is a very rare case. And as you see, we had the opportunity to find this fact studying for a big project we have with the Tokyo University, my university, and the Al-Qura University, because we designed in the first rail line in Saudi Arabia to support pilgrimages, the pilgrims for the Hajj, the holy pilgrimage at Mecca, that is one of the most important place for crowd, for managing the crowd. And we starting to observe, to study the problem, and we immediately realized and we transported this model to all the other kind of people. So it is a big, big change of mind to see that. So all the models based on physics, pure physics, disappear. In fluid dynamics, you cannot model groups. Stop. I challenge any people who can, and if they want, they can try, but it is not my topic. It's not. So we had to design the fact that we have a double rule that is opposite, because in a crowd, I want to stay far from strangers, but I want to stay close to my group. You have to design a computational model representing a very complex system, dynamical system, when the interaction is guided by this principle. And to do that, I have to do this in a scientific way. Scientific way, it means that it's not just a tale, because now I am talking to you like a tale. But we need to validate and calibrate the models in order to have useful tools to support security, comfort, and design of the space and design of the crowd managers. Usually they are neglected. In Italy they are very neglected, but in other places it is not. So we developed this method that is a method allowing to study crowd, like in biology, in vivo, observing. If I want to observe your behavior here, it is in vivo. In vitro, with experiments like in a lab, and in silico, on a machine. Few words about. In vivo, this is, the sound you listen are pigeons, because we had the permission of the municipality of Milano, because the Milano Gallery is a fantastic place to make some kind of observation. And in this case, we wanted to study the granulometric distribution of groups inside of, it is not a crowd because there's a low level of density, but it is very, very interesting to see the behavior of groups, the shape and the behavior. And we had, but why the gallery? First, it's not raining. If it is raining the day of the experiment, because we use a lot of technologies, it is covered. Secondly, because of the floor. The floor is decorated, so we can have a lot of measurement through the floor. That is very, very hard for the other people who are studying with computer vision. But for our purpose, it was fantastic. So we have to understand what is useful for us. This is the kind of results we had. That is level of density, presence of group size and proxemic spatial patterns, trajectories, walking speed, groups of experiment dispersion. So we made, and you see the second one is couples. Now we are studying the world, the crowds of couples. Why? Because in an aging society, when I design smart cities and mobility and transportation, I have to consider that a large part of the population are couples. And when I say couples, it means not only badante, but also trolley, also all is considered as a couple. That is the first one, and we are designing it with Central University, Florida, and Tokyo University. We are studying couples. This is in vivo, observing their reality, phenomenological approach. In vitro, only in Japan you can do in the best way this kind of experiment. They are fantastic, and there is a group, Professor Katsuhiro Nishinari group at Research Center of Advanced Science and Technology. We have a very, very strong collaboration, and we made, this is the measurement of the proxemics, when you can say, this is the distance, and this is culturally determined, because the proxemics in Japan is very different from Italy, South of America. So it is impossible to have a generic, not a general, a generic model. And in silico, this is one of the first results. We have a new, because usually, I confess, we use only very, very rough methods, but it is very impressive for the people, for when you want to explain. This is the Galleria, this is the result of our, because we have to fit with measurement what is the reality of the group dispersion and the group behavior inside. Now we are integrating with Unity, with all this kind of fantastic software, but I can announce now that we will have the first, but I explain you later, that is challenging the challenge, because the next step, one is from certification to real-time and to virtual space. I make you a little example, okay? Certification for crowd dynamics is mandatory in England. It is not mandatory, but Expo, they imposed for the pavilions to have also this certification. There is very good software, but the challenge is how to integrate it with social networks and sensor networks in order to have a global system, and we will have the first integration for security at the platform of Expo. So, I show you, it is a 2-minute movie to show you the integration of all this, and it is about makeup, but the message is we have to go towards a convergence platform. And I want to use the term platform because I have been invited to collaborate with the magazine platform of Simona, and I am going to continue this kind of discussion with you about that. So, this is the experience made in collaboration with a movie director from Saudi Arabia. that provided a lot of this material, and you can see a lot of pictures and movies are made by my group directly at the Hajj. I was not there, I am a female, it's complicated. It was to design the waiting rooms for the access to the rail station in Arafat. It is the 5th days of the Hajj when they have to go to Mina. Mina is the place where they have millions of tents where they sleep, white tents. This is the first opening of the rail station in Arafat. You see different kind of people. They are very expert to understand group by group in which way, what are the behavior, where they come from. This knowledge that we have not, but the crowd managers they have from thousands of years. This is in silico experiment, that is the merge, and it is an experiment made in Tokyo in order to fit this kind. You see, we take measurement and we put. It's incredible, but it is. This is for wheelchairs, because the aging population is affecting the edge, because also the people coming from advanced countries that are Muslim, they want to visit. This is a very, very important, that is the corner, how to fit the corner. The behavior of Japanese are like all the other part of the world in this case. So you see that is very, very nice, because we have to pass. And you see the white hats are because we are video cameras on the top, and it is easier to find the track measurements. So you see that this is the Arcast place in Komaba campus. This is a group that is stopped inside, that is producing turbulences. And this is a group in 2 leaders. This is different shapes. And these are Tokyo University students, so they are very, very nice and very quiet. And this is an example to go around in order to fit this one. And this is the system we realized, where we take the CAD files and we populate with a granulometric size and so on. So this is a synthesis of what it means to converge knowledge in a complex problem to fit with big problems. Thank you very much.